Hey guys, this is Mr. Sal. I'm working from home during the pandemic. Hope everyone's safe and healthy and doing that social distancing stuff. I just hope you guys are okay. But I know we got these lessons that we got to go over, starting with this 5.2 addition and subtraction with unlike denominators. All right. Now we talked about this in the last lesson. The need for common or like denominators. Because when we do something like this, and the diagram here shows this very nicely, which is part of the problem with adding fractions that don't have the same denominators, right? 1/3 plus 1/4, I mean, what is that overall? You can see the size pieces are not the same, so when we combine these two, we have two pieces, but the two pieces are also different sizes. So, I mean, you could say overall there are two pieces, but one of the pieces is much bigger than the other one. So it's important that we be able to cut these down into smaller, in this case smaller, more equal sized pieces. Now, not that we need these parts right here, right? However, by comparing these with these size pieces, right? So this part right here would be the third, and I'll color this one purple right here, the 1/4, right? Well, when we cut these into 12, like if the whole thing right here, right? Again, this would be 12 out of 12 parts, the whole black bar. Now, a fourth of that is these three right here that we've already highlighted. And then the third would be these four parts right here. Well, now, why is that important? Is because we can take those four parts from the 1/3, and we can take the three parts from the 1/4, and like we saw in the last section, we can add those. Well, now we have 7 parts, but then we need to look at 7 parts of what? Well, these are all in twelfths down here, right? So it'd be 7 parts of 12 parts. Now again, if we had 12 total parts, then it would have created a full piece. But a third plus a fourth wouldn't be enough to create a full piece, which when we do, we'll get some mixed numbers, but that's for a different section. So again, this is just illustrating the importance of having common denominators when we add fractions. Let me take that back. Not only when we add fractions, but when we subtract them as well. You have to have common denominators. Now in this first example, we may very well ask, well, we have two different denominators. How do I force them to be the same? Because in that last example, it kind of showed us that these were in twelfths already, right? But how do we know that these need to be in twelfths? Well, that's a good question. If we come up here to the 1/3 and the 1/2, I'm going to show this a little differently. We kind of went over this in the last lesson and also in class, right? I kind of look at this as two separate pans of brownies. Now the 1/3 I'm going to do here in red. Now I'm going to cut these ones vertically. Now the way we cut these is important because when we make cross cuts, then it's going to tell us how many pieces it ends up being. And I'll demonstrate that here in a moment. But if I took the 1/2 right here, now again I'm going to cut this one horizontally like this. And yes, my line's a little off, but please bear with me. So we got 1/3, right? Let's go ahead and shade this part in right here. And we'll shade in the 1/2 also. Doesn't matter which side you choose to shade on this. Something like these two. Okay, now, again, let's say that, well, I would assume that your pictures are better than mine, but either way. So again, I'm just going to cut both of these sheets, right? I'm just transferring these two lines. I'm transferring this one straight down this way. And then the purple line I'm going to cut in the other pan as well. Now again, the reason why I would do this on a diagram, not that you may like the diagrams, but the reason I'm doing it is so that I can see how many pieces I get when I make these cross cuts. And I can see that each of them now is in sixths. So the 1/3 is now in sixths, and we could see, well, how many is there? So there's 1/6, there's 2/6, right there, and then the purple, right? This one is also cut into sixths, but how many? There's 1, 2, 3 sixths right there, and these two fractions are being added. So if I combine these into one pan, let's say that I was going to combine them into the pan with the purple pieces. Well, these 2 sixths, I could move this sixth right here into this open sixth spot, and I could move this one down right here into this open sixth spot. And then how many sixths do I get when I combine these? 5 sixths. And we would have learned that in the last section. If I took the 2 and the 3 sixths and added them together, I could have made a fraction like this one. But in any case, we should end up with the same fraction right here as 5 sixths. Now I know some of you guys don't like the diagrams, and that's okay. I'm going to show this in a different way, in the more mathematical sense of the way that we would look at this, alright? Now there's lots of applications, and you kind of have to figure out what your own applications are if you're struggling to understand, like my brownie example right here, right? Is I make the red cuts, and then I make the purple cut, but then I put both cuts in both pans to see how many pieces and how big the pieces are. Now for me, brownies are very applicable because I love brownies and I eat lots of them. You could have said, well, we could do it with bacon and that would be fine too, or even perhaps a sandwich, but pans of brownies, at least visually, tend to look better. And again, I do love my brownies. But in any case, you kind of have to figure out your own application and then figure out how you would do it. Like, money wouldn't even work in this example, right? You could take a third of a dollar and add half a dollar. It really wouldn't make sense because there's no such thing as a third of a dollar. I mean, you can get pretty close with 33 cents, but it's not really exactly a third of a dollar. So let's go ahead and look at this in a more mathematical sense in the next problem right here. Now before we start this problem, I just want to point out once again, if we look at fractions, let's look at, it doesn't have to be a very common fraction, but let's look at a fairly common fraction, 3/4, like this, okay? Now 3/4 could be expressed in lots of different ways, just like we did over here with the 1/2, for example, right? You could say that you have half a pan of brownies, but you could also say that you have 3/6 pan of brownies. It just depends on how many times you're cutting this. You have 3 pieces out of what would have been 6, or maybe you had 1 piece out of what would have been 2, which is more my size type pieces. But in any case, 3/4, we could show 3/4 as something like 6/8. And the question becomes then, well, how do I get 6/8 from 3/4? These are equal, meaning if I had 3/4 of a sandwich and you had 6/8 of a sandwich, you would have the same amount of sandwich that I do, assuming that both sandwiches are the same size. So, how did I do that? Well, I just took both of these values and I multiplied them both by 2. Now this is called scale factors. I have factored or scaled the fraction 3/4 into something which may be more applicable, it just depends, right? And have gotten 6/8. And it's an equal amount of value to what we started with. Now let's go back to that 3/4. So let's say that instead of 6/8 we wanted something else. Well, as long as you're multiplying the numerator and the denominator by the same thing, it's not going to matter. Let's say that we wanted these multiplied by 5. Whatever you do to the top, you must do to the bottom, and that's going to create a new fraction, which would have been 15/20. Okay, now why am I doing this? Well, I just showed that I can get 15/20 from 3/4. I could get 6/8 if I wanted to. And if we wanted to go a little bit deeper, you could say, well, you could get 9/12. You could get 12/16. And all of these fractions have the same exact value. But what do you notice about the fractions, and this is important to notice, is that all of these fractions, they have the same values, but the denominators are all different. What this means is that we could technically, especially once we go through the decimals unit, we could technically change any denominator into whatever denominator we want. So let me demonstrate this a little bit further, right? Let's say that I had 3/4. Let's use subtraction this time. Let's say I was subtracting, I guess we'll use twelfths, something like 5/12, right? Something like this. Well, I could easily change the 3/4 into this fraction. It's equal, it's the same exact value, 9/12, and then I would subtract my 5/12 right there. Okay, and what has just happened? I have two denominators that are the same. Now I could have scaled 5/12 if I needed to. Maybe it was 10/24 or something like that. Depending on the denominators, and what I'm pointing out here is that you could change this fraction into an equal fraction, but with a different denominator. And as long as we understand that we can manipulate or change the denominators as we please, we can add any fraction as we please, because whatever the denominators are, even if they're different like this, we can force them to be the same. And for this example that we're going to be doing here, yes, I am going to have to change both denominators. Now you may be wondering, well, how do I know what denominator to use? And this is where we come into, it doesn't have to be the least multiple. Let me take that back. It doesn't have to be the least common multiple for both denominators. It just needs to be any common multiple for both denominators. Now in this example, because 5 and 2 are kind of low numbers, we're going to look at these as the lowest common multiple, just because it's going to happen kind of quickly. So I'm going to look at the 5s first, right? 5, I have 5, 10, 15, 20, right? Now that's going to be a lot for multiples of 2. So let's do multiples of 2 here on the side. So the first multiple of 2 is 2. 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 is 10. Now I'm stopping there because I have two multiples of 5 and 2 which are the same. Specifically, I'm looking at 10 right here. Now we come to the problem, and we need to ask ourselves, what do I multiply 5 to get 10? Well, I would have to multiply it by 2, right? Now that gives me a denominator of 10. But remember from the last example we just did, is if I do it to the denominator, I must do it to the numerator as well. So 3 times 2 would make 6 tenths. And what about the 2? Well, I would have to that's the fifth multiple of 2 right there, the 10. So I'd have to multiply the 2 by 5. Which means I also must multiply the numerator by 5. And 2 times 5 is the denominator, 10. 1 times 5 is the numerator, 5. And what operation are we using here? Addition. So I can add these together, and since I have common denominators, I will show this step. I have 6 plus 5 in my numerator, and we're comparing these in tenths. 6 plus 5 is 11, 11 tenths. And that would be our final answer. Now, yeah, some of you are like, well, I definitely need to change that into a mixed number. That is not true. This assignment never said that we needed to. You could if you wanted, but I'm going to stop right there because it takes away that step, which opens us up for making some of those small errors. So we've done a couple examples. I would recommend pausing the video to try some of these out. However, you've had your chance to pause it. I'm going to go ahead and do this problem. But again, I do recommend pausing and trying it out on your own. So let's go back to that same method that we just saw, right? So I'm looking first at this denominator of 12. And the multiples of 12, 12, 24. Now that's a lot for 3, which is what we're comparing this with. Just focusing on the denominators. I'm not worried about the 5 and 1 right now, right? So let's look at multiples of 3. 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. And I notice that the 12s are common right here, right? These are the common multiples. Now this is nice because this fraction already has a denominator of 12, so it stays 5/12. The 1/3, however, needs to be changed into a denominator of 12, so I'm going to write that in. I know it needs to be 12. But how do I get 12 from that? Well, this right here would show that 12 is the 1, 2, 3, 4th multiple of 3, which means that I would have had to multiply it by 4. And I must multiply the 1 also by 4, making 1/3 the same as 4/12. And yes, this is addition. So once again, I have my common denominators at 12. I can combine the numerators, 5 plus 4. And what do I get? 5 plus 4 is 9. 9/12. Now that was pretty awesome, right? We did a great job. It was a lot of work. We had to do some thinking. And we feel pretty good about it, right? The problem with this, and just like we talked about in 5.1, is whenever you get answers to these problems, you need to stop and just think, can you simplify these? And the good thing about this is that 9 and 12 are already both in the list for common multiples of 3, which means both of these are simplifiable by 3, or by a factor of 3. And what do we get when we divide both of these by 3? 9 divided by 3 is 3. 12 divided by 3 is 4. So 5/12 plus 1/3 ends up being 3/4. And this would be our final answer. 3 and 4 do not have any common factors to cancel out as phantom ones, so that's just it for that one. Now we're going to look at this next example from the next page, which is subtraction. So again, I'm just going to point out from the 2/3, right? And these are drawn pretty accurately. Cut in half. Now it is 2/3. We got our 1/3 right here, and then our other third right here. Now in this example, we're subtracting the 1/4 right there. And yeah, you can see the answer. That's fine. But again, I'm just trying to explain how this works. The 1/4 is going to be coming off of that, particularly this part of that 1/3. That's coming off because I'm subtracting it. So eventually this is going to go away. Now again, we are comparing these in 12ths because then we can compare the same size pieces on this. So the 1/3 we can see would have been 4/12, and then another 4/12, which would have made that as 8/12. And then the 1/4 would cover this many 12ths, which appears to be 3 of the 12ths. Now we're going to be subtracting these, and just like we saw in the last unit, when we are subtracting, we need those common denominators. And when they are the same, we can take the two numerators and just simply subtract them. 8 minus 3 is 5. And then again, we're dealing with 12ths on this. Now again, the question becomes, well, how do we know how many pieces to cut this into? How do I know that I need 12ths? Well, if you're using diagrams, it's pretty simple if we use the same method we used for addition. So let's go back to, again, the brownie example, which is very applicable for me. So we're going to take this brownie pan and this one, and we'll just set these next to each other. These ones are the same size because of technology. Now the 1/2 on this one, I'm going to cut it this way, alright? And this is going to be our 1/2 right there. Now, the nice thing about this example is the 1/2 is first, so it's good to point out that it doesn't matter which cut is which, as long as the two cuts are different, meaning my 1/2 now is cut vertically, whereas in the last example we cut it, it was horizontal. And my 1/3, I'm going to cut this one horizontally. Now yes, hopefully your lines are better than mine, but I'm going to shade in one of these thirds to show this piece is still remaining of the 3 pieces. Now again, both of these pans are the same size. So what am I going to do? I'm going to cut this brownie pan this way because this one was cut right here. And then I'm going to take these two cuts right here and place them in this brownie pan, which is going to change these into sixths, right? And the 1/2 is now 3 pieces out of 6. And the 1/3 is 2 pieces out of 6, which we are going to subtract. And what I mean by that is this piece right here is going to zero out, or it's like it's canceling this piece. These pieces cancel each other out. And then this orange piece, which is a sixth, will cancel out this piece right here. Now, just from what I explained right there, hopefully it makes sense with what the answer will be, because I am subtracting these. And that would end up being just this last piece up here, this one right here, which is 1 piece out of 6. Now again, if we go back to the last section, it's the same as taking the sixths. I should make that one fraction. And I would take the numerators and subtract those. 3 minus 2 is 1. And that right there would be our final answer. Now, again, you should look to simplify if it's necessary, but it isn't always. I do want to point out again that hopefully this is helpful for you guys to see, at least with diagrams, how to make common denominators. And we showed just finding multiples of both of the denominators when we're subtracting, but it's not necessary to do that. There's another method. So try this example. Again, pause the video, try it out, and we're going to do it. Now, try it with the common multiples of 4 and 6, right? Now, some of you may have seen, well, I could use 12, I could use 24 or 36. There's lots of multiples that are the same. But let's say we just weren't good with these two multiples, 4 and 6. Well, there's something you can do to force denominators to be the same. Meaning by the time I multiply these out, I will have the same denominator. And here's what we're going to do. Okay, I'm going to look at the 3/4. Particularly, the 4 is in the denominator. What I'm going to do is I'm going to multiply that denominator in the other fraction, both the numerator and denominator. Now, the other fraction in this case is 1/6. So I'm going to multiply 1 by 4 and 6 by 4. And what does that give me? Let's put this up here. 1 times 4 is 4, and 6 times 4 is 24. Now, if we do this right, it's going to force this other denominator to be 24 automatic every time, no matter what. How am I going to do that? I'm going to take the other or opposite denominator and multiply it into the numerator and denominator. And we can see that it's the same expression, right? Over here, the first one we did was 6 times 4 to give us this 24. Now it's 6 times 4 here in the red, which is 24. It's the same exact expression. It's just the numerators are going to be different, because now my numerator, 6 times 3, is 18. And the operation here, subtraction. So this will give you common denominators every time, in this case 24, and this would have been 18 minus 4. And what is 18 minus 4? Well, that's 14. So now I have 14 24ths. Now again, we should always check at the end, just make sure that this can be simplified. Or if it can be simplified, check to see if it can be simplified. And I know both of these are divisible by 2 because they're both even. Now, that's a pretty easy way to start, and you could say, well, maybe there's some other bigger factors that we could divide these by. I'm not really concerned with that right now because we're still getting used to this technique, and that would just be one extra thing to worry about. So 14 divided by 2 is 7. 24 divided by 2 is 12. And then I check again, is there anything else I can simplify these by? And in this case, no, there is not, which means the final answer to this problem is 7/12. Alright, again, please try this example, pause the video, and give it a shot, and then when you're ready, just unpause the video. In the meantime, I'm going to go ahead and get started. Now, this one's really nice. This one's really nice because 8 is already a multiple of the 4 right there. So I'm not going to use that same method that we used in the last one. Again, that's just it's a common method that's used to force denominators to be the same. But if we notice that the two are, or one of the two is multiple of each other, then we can just use those, alright? What this means is that I'm going to make the 4 here an 8 by multiplying it by 2. So, again, I got to do it to the numerator as well. So the 7/8 stays as 7/8. Now the other denominator, if we did it right, should be 8. And 4 times 2 is 8, which is nice. Then I've got the 1 times 2 in the numerator, which is 2. And again, this is subtraction, right? So I'm dealing in eighths. How many eighths do I have? Well, I had 7, and I'm going to take away 2 of those eighths, which ends up being 7 minus 2 is 5, and again, the same size pieces, we're still dealing in eighths. Now this specific one cannot be simplified, so I'm going to leave that at 5/8. Alright, so here's that next example. We'll give it a shot, then we'll go over it. Alright, you had your chance to pause the video. This one's going to work exactly the same way. 10 is a multiple of 5. So I'm going to take the 10 and the 5. I'm going to make the 5 a 10 by multiplying it by 2, which is going to give me 10. Just don't forget to do it in the numerator. 2 times 2 is 4. So now I got 7/10 minus the 4/10. And again, I'm only dealing in tenths. So I would take 7 of them and subtract 4 of them, which would give me 3 of the tenths. So I've got 3/10, and this, again, cannot be simplified, which is nice, and we have completed that problem. Alright, for these next few examples, we just got to find the lowest common denominator, or least common denominator. And it looks like for these examples, we just want to know what the least common denominator is. This is a great skill, because when you find the least common denominator, you can add and subtract fractions. Now, it's nice because it is also the least common multiple of each, which we've gone over before. Now, in the examples that they show here on the left, they're using the prime factorization of these numbers, which you can do, alright? And I will do this first example with the prime factorization, just because that's the way that they have it shown here on the left. So you can compare what we have there on the left with the way that I'm going to do it right here, but I'm going to be circling them a little differently. Now again, I'm not worried about changing the fractions right now. All I want to focus on is the 10 and the 4. So 10, if I looked at its prime factorization, I would split it up between 5 and 2, both of which are prime. So 10 is the same as 2 times 5. And 4 is the same as 2 times 2. Both of these are prime. So I look at 4, and I find that it is 2 times 2. Now, the way we did this in class, right, is I would take these values and find the lowest common multiple. And to do that, I would look at the list, and I want to find any matches between the factors of 10 and 4, which I'm just going to circle these 2's. Now that comes out as a single 2. Now that's the only 2 values that have matches. The other 2, let's look at the 5 first. That one doesn't have a match, so it still goes in the list, and it's still multiplication. The 2, this other 2 I should say, does not have a match either, so it also must be part of the least common multiple, and I must multiply that in these factors. So the lowest common multiple, which is the least common denominator, is just 2 times 5 times 2, which is 20. So this would be the common denominator that we would use if we wanted the lowest common denominator. Now remember this though, the way that we're doing this produces the lowest common multiple. It's just not necessary to do that. Okay, now again, what I mean by that is if we had some kind of maybe addition between these two. You could use the method where we took the 10 and multiplied it by 4 and the 1 by 4, and then we took the 10 and multiplied it by the other fraction, numerator and denominator. And that would change these fractions into common denominator fractions, but it wouldn't be the lowest common denominator. Now what that usually means is that you have to simplify after you use the operation addition or subtraction. But again, sometimes you have to do that even when you find the lowest common multiple or the lowest common denominator between 2 or 3 fractions. So just keep that in mind. Sometimes you have to simplify even if you find the lowest common denominator. It just happens from time to time. So whichever method that you're liking better, use it. Alright, so this example right here. Okay, so let's use just the list like we had done before, instead of the prime factorization. So I'm going to start with 25. And again, I'm not worried about the numerators right now. Don't worry about those. Just focus on the denominators. 25. Well, let's list multiples of 25. So 25, of course. 25 plus 25 is 50. Plus 25 is 75. Plus 25 is 100. And, you know, you could keep going on like this if you wanted to. But let's look at the 20 right here and just see if we can find one that's common. So 20, the first multiple of 20 is 20. 20 plus 20 is 40. Plus 20 is 60. Plus 20 is 80. Plus 20 is 100. Now again, you could continue on like this if you wanted to, but I already see that the 100s are common multiples for both. Now, is it the lowest common multiple? Well, you'd have to look in the list. You're just looking directly above it, and there are no common factors in either list, which means that the lowest common multiple or the lowest common denominator for both of these would be 100. Alright, try this one out. Pause the video. Just give it a shot. And when you're ready, unpause the video. Alright, now this is actually a pretty nice one. Some of you are wondering what the denominator of that 2 is. It's a 1. I could write that easily as 2 over 1. Now, whatever the other number is, that's going to be your lowest common multiple for both of these, as long as one of the denominators is 1. Right, because you'd have 1, 2, 3, 4, and then you'd have a list like this. 4 is the lowest common multiple for these. So you could say lowest common denominator, lowest common multiple, it won't matter, it's the same thing. 4 for this problem. Alright, so what are we doing with an example that has 3 separate fractions? Well, everything works pretty much the same, and you could use any of the methods that we've talked about. But this one specifically does want the lowest common multiple. Now, the nice thing about this is one of the denominators is a 5. So I'm just going to list the actual common multiples, 5, 10, 15, 20. Now I can stop there because one of the factors is, or one of the denominators is a 20. Now, if you've memorized that multiplication chart like we said we should earlier in the term or the semester, then you'd know that that's as far as we need to go. But you could have gone further if you needed to. You would just notice by making these lists that we don't need to. For example, 4. Let's list the multiples of 4. 4, 8, 12, 16, 20. Now again, we see this common number, 20, in all 3 denominators, which means that the lowest common multiple for these is actually 20. And that is the answer for this problem. Now again, I'll point this out once again that you could have used the prime factorization to do this. It wouldn't matter. You would still get the same answer. You should get the same answer, I should say, as long as you're doing it correctly. Now for this next example, we need the lowest common denominator, but then we're going to rewrite both of these fractions with the new denominator. Now 15 and 24 are kind of big, so I'm going to be using this prime factorization stuff, okay? And hopefully you guys are noticing, just as you guys do this, you'll find these techniques, and then as long as you got them in your belt, you can use them. You can pull them out whenever you need to. So whatever occasion may come up, you'll just know what to do. Or that you'll have options at least, right? Like, do you want a wire cutter? Do you want a wire splicer? Do you want something to hammer something in with? Because, I mean, you don't really need a hammer all the time to hammer stuff in. You could use an axe. I don't know, maybe that's not applicable. But in any case, right? Let's look at 15. Let's split this up. 2 prime factors of 15, 3 and 5. Bam. As far as we need to go on that. 24, I would split this up into 6 and 4. You could have done 12 and 2, and that would have been fine. You could have done 3 and 8. It wouldn't matter. In any case, 6 would split up into 2 and 3, and 4 will split up into 2 and 2. Now, I have all my prime factors for both of these, right? So 15 prime factors would be 3 and 5. For 24 would be 2, 3, 2, and 2, like this. So, if I want my lowest common multiple, I'll have to take the match on these ones, which is the 3's, right there, and then all of the unlike, or the factors that don't have matches, which is 5, and then we got 3 2's, because I was just looking for matches within both sets of prime factors. Now I do have to multiply these out, so 5 times 2 times 2 times 2 times 3. I would regroup these differently. 5 times 2 is 10, and then 3 times 2 times 2 is 12, which would have been 120. So if I want a common denominator for these two, it looks like it will be 120. So 3/15 will be out of 120, and 7/24 will be out of 120. Now we are changing these fractions, the numerators as well. The question is, how do I know what to multiply them by? Well, they had the 3's in common, so whatever factor was in the other set is what I need to multiply the current set by. That probably didn't make a lot of sense. So let me start with the 15 here, okay? I'm going to change this 15 into 120. Well, how am I going to do that? Well, the 3's were in common. The 2's were not common, right? And what is 2 times 2 times 2? That's 8, which means I would have had to multiply 15 by 8 to get the 120. Which means I also have to multiply the 3 by 8 to get 24, and this would be the new fraction, 24 1/20ths, which has the exact same value as 3/15. So let's look at the 24 now. The 24 I want to change to 120, but how am I going to do that? What am I going to multiply it by? Well, the only factor that wasn't common was the 5, so I'd have to multiply it by 5. And you can check. 24 times 5 is... Oh, I wrote that wrong. 24 times 5, what would that be? Well, if you did all the math there, it's 120. So, if you multiply the denominator, you got to multiply the numerator as well. 7 times 5 is 35, and this fraction here would be the 7/24 with the same exact value, but a different denominator, just like they wanted. Now these next examples are kind of like what I did with the brownie pan. They're not cutting them horizontally and vertically, which I would recommend doing, because it works every time, as long as you're only dealing with 2 fractions though, and that's where things get a little fishy if you start looking at 3 different fractions. Well, then you got to cut it 3 different ways, and well, what other ways are we left with? And you just kind of have to see at that point. So we're only looking at 2 fractions for each of these, and it kind of does give us a step-by-step procedure for solving, adding fractions. For example, and this is nice again about math, is that it breaks down everything into smaller, more manageable steps. This is true all the way up into calculus and beyond, alright? So if you can get really good at this, you can do any type of math. You just got to be able to focus your mind on one of these steps at a time. For example, the lowest common multiple of 6 and 4 would be, you guessed it, 12. If you said 24, that would have been fine. You'll just have to simplify the fraction in the end. No problem with that, okay? So the lowest common multiple of 6 and 4 is 12. Alright, which means that I need to change the fractions into 12ths. Both fractions into 12ths. And yes, this is addition, so the question then becomes, well, how do I change a 6 into a 12? I'd have to multiply it by 2 to get the 12, which means I need to multiply the numerator by 2 as well, which gives me 2 12ths. And what do I multiply 4 by to get 12? 3. And that would give me 12, so I got to multiply the numerator also by 3 to get 9. 3 times 3 is 9. And then we actually add the fractions. So we're dealing in 12ths, which is okay. Let me write that a little better. There we go. So we had 2 12ths. And we also had 9 12ths, which we were adding. When I take 2 plus 9, I get 11. And we have this in 12ths. Now, before you finish this off, you should look for a way to simplify this, but this one is fully simplified. 11 and 12 don't go into each other evenly, so we're finished with this fraction. This would be the final answer there, 11 12ths. Now that process alone is very nice because you can use that process every time, find the least common multiple, change your fractions, add the fractions, bam. Well, again, you have to look to simplify at the end there. That's 4 pretty easy steps right there. Again, that's just by breaking the problem into smaller, more manageable problems. Alright, so let's do this problem the same way. We're going to find a common multiple, least common multiple, I guess, for these ones. Not that you have to. In fact, 16 and 14 are kind of different, so sure, let's use something different. For example, let's say we didn't want to use lowest common denominators. We just want any common denominator, which is okay. Well, I could multiply the 6 by the 14, which is the other denominator, right? Which means I also must multiply the 5 by 14. Now again, this is going to guarantee that our denominator is going to be the same. 14 times 6, let's see what that is. 4 is 24. Carry the 2, 6 times 1 is 6, plus 2 is 8. That's going to be 84 right there as our common denominator. And 14 times 5 would be 70. Now we're subtracting here. And again, I'd multiply the 14 by 6 to make that also 84. And 3 times 6 is 18. Now again, this is not using common or lowest common denominators, but we do have a common denominator, and that's all we're really concerned about right now. 70 minus 18 is going to give us 52. Now this is 52 84ths, and again, I just noticed, just right off the bat, that both of these are divisible by 2. In fact, they're both divisible by 4, but let's say that we didn't notice that, okay? 52 divided by 2 is 26. 84 divided by 2 is 42. So again, I can take this and divide it by 2 once again, which I will do. So I got to divide these by 2, and I got to divide these by 2. 26 divided by 2 is 13. 42 divided by 2 is 21. Now we have a fraction that is fully simplified. 13 is prime, and it has no common factors with 21. So that is the final answer on that one, 13/21. Now notice we got the same answer whether you used 84 or not. It was not required that you did. If you did find a different denominator, the lowest common denominator for these two, I believe, is 42. So if you did that, if you did use the 42 as your lowest, that would have been the lowest common multiple or denominator. If you used 42, then you would have been stuck at this point, which again shows that you would have had to simplify both of those by 2 anyways. So whichever method you get, you're going to have the same answer either way. And again, we're just showing, I'm pointing this out because you don't have to use the lowest common denominator. You may use any CD or common denominator. All right, let's try this one a little different. I will find multiples of each of these just because they are, well, they're kind of easy, I guess. 20 specifically is 20, 40, 60, 80, 100. Let's see how that does. And yeah, some of you guys know what it is already. 15 plus 15 is 30, plus 15 is 45. We're pretty close. Plus 15 is 60, and that's going to produce a lowest common multiple for each of these. But again, this may take a little bit more work for some of you because we have to figure out how many or what multiple it is of both of these, right? For example, I'd have to take the 20 and I would multiply it by, that's the 60 is the third multiple of 20. So the 6 also by 3 becomes 18/60ths. And we are subtracting those. And the 60 for the 15 is the fourth multiple, so I'd have to multiply it by 4, which means 2 must multiply by 4 also, which gives me 8/60ths. Now we're ready to subtract these, right? We got 18 minus 8, which is 10. And yes, I did kind of skip a step right there, didn't I? It's not required that you show that step if you know that you're just taking the numerators and subtracting them and keeping the denominators the same. Now that I got 10/60ths, actually what I would do is I would probably just cross out the zeros to make this 1/6. Now crossing out the zeros is the same as dividing both of these by 10. Both of them work. It's going to give you the same answer, 1/6, which is fully simplified. Alright, let's go ahead and get started on this last page of the section. Try these 3 out though. Pause the video. Try all 3 of them out. Then we're going to go over all 3 of them, alright? So if you pause the video, there's a good time to do it. If not, we're going to get started on this one here in the bottom left. Now 18 and 28, again, we need to find common denominators first, which 18 and 28 is just, they're not great values. We know 18 is a multiple of 9 and 28 is a multiple of 7. It's just going to be, it's just going to kind of be a hassle no matter how we do this. But the fastest way for me on this one would be to multiply the 2 values together. So, in other words, is I would be taking the 18 and multiply it by 28. So the 5 I would multiply by 28 also. And the other denominator in this case for this one is 18. So I'd multiply these by 18. Again, this is going to guarantee that whatever denominator it is going to be exactly the same. So over here, I'll do the work. I got 18 times 28, right? Now it doesn't matter which of these is above or below each other. 8 times 8 is going to be 64. 8 times 1 is 8, plus 6 is 14. Now I'm in the tens place. 2 times 8 is 16. 2 times 1 is 2, plus 1 is 3. So I'm just going to add these together to find my total product. 4 plus 6 is 10. 1 plus 1 plus 3 is 5. So my new denominator is going to be 504 for both cases. Now 5 times 28, that's going to be 140. Oh, wait, a little backwards there. Let me fix that. 140, there we go. And 3 times 18 would be 30, 48 for that one right there. And yes, we are adding these two together. Now again, notice that, I mean, maybe that wasn't really fast, but it was, I would say it's probably relatively easier than going through all of the prime factors, multiplying those out, seeing which ones don't match, and then kind of pairing them up there. Now again, this may not be the lowest common denominator, but again, we don't worry about that because whatever we get, we can simplify after this. So 140 plus 48, that would be 188. And 504, that's our denominator, 504ths, I should say. And I notice, first of all, that both of these are divisible by 2. So what would that give me? It looks like it would give me 94. And 504 divided by 2, looks like it would be 252. So again, we can divide these by 2. Once again, we'll divide these by 2. I'll have to write my answer over here. I'm running out of space there. 94 divided by 2 appears to be 47. 252 divided by 2, 126. Alright, so we've kind of arrived at an interesting answer here. 126 and 47. 47, I believe, is prime. I can't think of any factors that go into 47. And 126 is not divisible by 47. So, since that is the case, this is actually our final answer. Now again, whether you use the lowest common denominator, which I assume would be the 252, this took 2 simplifications to get our final answer. But if you had found the 252, you probably had to make this final simplification anyways. Alright, I'm doing this a little out of order, and this one has the same denominators as this problem that we did earlier, so I'm going to kind of keep it up here on the side. And the reason I'm doing that is because it looks like our lowest common multiple, not that we had to use it, is, or it was, 120. And you'll want to keep these in mind because sometimes this happens in homework where they use the same denominators. They'll just change the numerators just like we see on this one. And in fact, they're showing an operation on this one too, right? I know that whatever denominator I use, I'm going to just use 120 for this one. And how did we do that on that last one? Well, we can see that we had to multiply the 15 by 8, which means I had to multiply the 4 by 8 to get 32 there. And the 24 had to be multiplied by 5 to get 120, so 5 by 5 as well gives us 25. And yes, this is addition here, so we're going to add these two together. Still looking at 120ths, but 32 plus 25 would be 57. And 57, it is divisible by 3. How do I know? Because 5 plus 7 is 12. And 120 is divisible by 3 because 1 plus 2 is 3. So this is actually simplifiable by a factor of 3, just to start out with at least. 57 divided by 3 would be 19, and 120 divided by 3 would be 40. Well, now I've reached a point which cannot be simplified. 19 is prime, and 40 is not divisible by 19. So this is my final answer on that one. See how that was nice to see from a previous example? I already knew what to multiply the 15 by up here, and the 24 by also, to get this common denominator of 120. So it's not that we have to keep track of those, but when you see two numbers that you're like, maybe I've seen those before, just check your notes, especially when they're as unusual as 15 and 24, okay? Because you can find them pretty easy if you just kind of look back. Now, yes, of course, it would be a lot easier if you could use a calculator, but we can't use a calculator in this class. So you kind of have to check back and forth, especially with these unusual numbers. Alright, well, what do we do with a problem like this one? There's a few things you can do, of course. But one thing we should notice, just to start out with, is that 6 is a multiple of 3. And the 15 here is also a multiple of 3. 3 is kind of the key number from this. The problem is that 15 is not a multiple of 6. But again, knowing that it's a multiple of 3, 6 is a multiple of 3 is crucial on this. Because what I can do is, since 6 is a multiple of 3, well, what would it be times 2, right? If I multiply the 15 by 2, then I will have a denominator that is the same. Or that I can make these other ones the same, right? So if I multiply 15 by 2, I can multiply the 6 by, what would I need to multiply it by to get 30? I'd have to multiply it by 5, which would make it 30. And so the 3 I would have to multiply by 10 to make it a denominator of 30. Well, now that I've changed all the denominators, I can change all the numerators correspondingly. I'm multiplying these each by the same factor that I multiplied the denominators by, which would give me 6/30ths there, 10/30ths there, and 25/30ths here. And this is all addition. And again, the nice thing about having those denominators is once I have them, I'm only dealing in this size piece. So I would have 6/30ths plus 10/30ths plus 25/30ths. And how many 30ths would that be? 6 plus 10 is 16, plus 25, looks like it'd be 41 right there. Let me just double check. Yep, that looks good. 41 is not divisible by 3, 10, 5, 6, or 2. So I'm just going to keep it like this. Again, if you wanted, because you're like, man, I just need to see that mixed number, you feel free to do that, okay? But I don't feel the need to. Again, it opens me up for more small mistakes, which I tend to make. But again, if you feel more comfortable doing that, that's fine. This one would be 1 11/30ths, just so you know. Alright, this next section, I'm going to do the bottom one first, just because when you take a whole number and just add a fraction like we do on this one, this is actually, well, it's kind of the definition of a mixed number, which would mean that the final answer, you could just write it as 3 5/9. How awesome was that one right there? 3 5/9, 3 plus 5/9 is 3 5/9. Subtraction is a little different, though. We can't necessarily just do that with subtraction. And the reason that is because we're taking stuff away. So what we've got to do is we've got to take that 1. Now, I like to show that phantom 1 as the denominator because it clarifies exactly what size pieces we're dealing with here. And it helps me to know what I'm trying to get out of the denominators, right? I need a common denominator, which in this case is going to be 4. Now, how would I make a 1 a 4? I would multiply it by 4. So I'd have to multiply the 2 by 4. Now, again, just think about what this means, okay? 2/1, or a full value of 2, is the same as 8/4. Now, fourths is nice because we can compare this with money. $2, right? Like this. It's the same as having 8/4, and that's what this is showing right there. Now, we would be subtracting this with 3/4. So 8/4 minus 3/4. And again, we're dealing in fourths, but I would look at this as 8 minus 3, which is 5/4. Now again, I would keep the answer like this. If you wanted the mixed number, of course you got 1 and 1/4, right? Now, one thing they may be trying to point out on this, just one thing, and I'm not completely sure, but it doesn't really matter, is that 2 would be the same as 4/4 and then another 4/4, right? That would be 2 whole parts. And then if you subtracted that 3/4 right there, you could essentially group these two together. 4/4 minus 3/4 would be this 1/4 right here, and then the 4/4 is just the 1, which is why you end up with 1 and 1/4. Now again, that was just kind of explained, but maybe that makes more sense to you if you look at this in terms of mixed numbers, which is okay. Well, I hope this was helpful for you guys. Fractions aren't everyone's favorite thing, but I hope this has helped you guys out. Again, be careful with these fractions. You have to have those common denominators. Yes, they are dangerous. They have destroyed people's lives before, so make sure you treat these with kindness, with care, and find your common denominators before you ever add and subtract. It's not required for multiplication or division to have common denominators, but it is when you add and subtract with fractions. Alright, we'll see you guys in the next one.